So there's been more overlap in the use of the term squares. So sometimes I'm like, well, hey, 81, I can get that from 9 squared. So, those are nice square roots. And then we have the difference of squares, and then now we have perfect squares. And here is a friendly reminder from a previous section. The quantity x plus 7 ends up being x squared plus 2 times b, which is 2 times 7. So there's 14x plus 49. So what this means is there's going to be a couple things that show up. When you go to factor these, you're going to want to see something that has x squared, but I'm going to write it instead with a. So a squared plus 2ab plus b squared works its way backwards to become a plus b squared. Now, pattern-wise, the other deal would be, what if you had a minus going on? So if you had a squared minus 2ab plus b squared, this would work backwards to a minus b squared. What makes this different from earlier sections is earlier sections had us foiling this out, but now we're going from the expanded form to a factored form. And I look at these and I'm going to study for a test, or maybe I'm trying to memorize this. I'm like, okay, cool. It kind of makes sense to me that the pluses would always be plus, while with the minus, this final term always gets multiplied by itself to become positive. So the only thing that makes these very different is seeing this minus symbol here and there. So however you choose to memorize that, just make it happen. The instructions for these, where we're told to factor perfect square trinomials, tri meaning 3, we're going to have 3 terms. First, you have to determine whether it is a perfect square trinomial. If so, factor it. So we look at number 1. Feel free to pause and give yourself some time to think about it, because maybe I'd like to see if I can reduce the value of these numbers. So as a starting point, I'm going to take 16 out from everything. So I'm going to pull out 16, leaving me with x squared plus 2x plus 4. And the reason I'm doing that is because I'm thinking that, if this is that a value squared, and this is that b value squared, then we'll see if this is 2ab. So in our case, a is x, and b would be 2, because 2 squared gives me 4. And does that work out to where we have a 2ab deal? The issue is that it doesn't. So we would really say, no, this is not a perfect square trinomial. Now, technically, we still factored it. And we probably would to err on the side of caution. So let's put no, not a perfect square trinomial. It's harder for me to do handwriting down here. Make sure yours is neater than mine. And let's do a little quick check. Let's assume you approach this from a different angle. You saw that 16x squared. Maybe you were thinking that could be 4x squared for a. And then maybe you thought the 64 would be 8. So you could just test it out and see what happens. And if I FOILed this, I'd get 16x squared plus 2 times 4 times 8, which would be 64x plus 64. And then you can see how that 64 value is double 32, which was the same problem we ran into the other way I wrote it. Pause this if you need to look at some of the work, or jump back to the video earlier on to see what I was referencing. We'll move on to number 2. We got 9y squared minus 12y plus 4. Now, unlike the last problem where we could factor out 16, I probably want to do a quick scan and think, well, I could pull out 1, 2, or 4, which would work here, but not with 9. So we can't pull anything from this. So let's assume that it's a perfect square trinomial. So over here I'm going to, in red, find 9y squared square root, which is 3y. And then 2 would have been squared to get 4. And since I see that minus sign, I'm assuming I should test it with a negative. So here I'd get, I'll write this one out this time, 3y minus 2 times 3y minus 2. They're called perfect squares because, like with the area of a square where you multiply a side by itself, that's what's going on here. So we have 3y times 3y, 9y squared. The outside's minus 6y. The inside's minus 6y, and the last plus 4. And when I put all that together, let's see if we get what we hope for. And it actually matches up. So that was just me assuming something, right? So let me go at it from the other angle too. Now this would mean that A would have to be 3y, B would have to be 2, and to get that inside part, it would be 2ab, which would end up being 2 times 3 is 6 times 2 is 12y. So this one does nicely do it. So hopefully you're okay with either way I'm thinking about it by now, or rewatching these videos to see if they coach you through it again. And the reason I say that is because I think that when we just force ourselves to memorize formulas, we end up never retaining things, but when we try to picture it and try to work through it and test things out and experiment, I think that helps us do it. Now, I think that's probably enough for 3 and 4. So we'll make 3 and 4 OYO problems, and I'll put the answers up in just a moment. So here on the left, through trial and error and, just testing out n minus 12 squared, I got that to match that. And when I saw this, I saw, well, 81 square root would be 9. And so I went ahead and I FOILed this out, but I got 18x and not 9. And so I have to go in and add an extra detail here where I say, okay, no, not, and then please write out the words a perfect square trinomial. I just don't have room. But then I could also show it the pure formulaic route for 3 and for 4. So if a is n, then b would be 12 because the square root of 144 is 12. But then 2 times n times 12 would be 24n, which does check out. And I'd know it would be subtraction because of how the formula looks. On the other side, if a was x and b was 9, because that's the way they match up, then 2 times a times b would be 2 times x times 9, which would be 18x. And that does not agree up there. So let's move on. A lot of these are heading towards the same instructions of factoring something completely. And they show us a new tool, and then we have to apply that tool. So like before, now we might have less clear instructions of how to move forward with this. And maybe there's some that do and don't look like the ones we just did. Oh, whoops. I thought I was not recording. Sorry about not talking. Go ahead and write number 1 down. We got 4x squared minus 36. Now, these are trinomials, so I guess that's not what we have going on here. We got a binomial, so I'm probably not going to do the same thing. Your decision. I personally would like to get that 4 out because I have an easier time spotting lower values. So there's x squared minus 9. Oh, cool, we got a perfect square. So this would be 4 times x plus 3 times x minus 9. And if I had done it differently, not pulling that up from the start, it just means I would have had to have factored out a term later on. Let's see. Might have some room to fit number 2 down here. So here's 2. 25x squared plus 5x minus 6. Now I can't take anything out from 25 and 5 other than 5 or 1. And since I can't do that for 6, that's not happening either. So there's no greatest common factor yet. The highest degree is 2, while this would be 1, and there's no x here, so I can't pull out an x or anything. So we got another trinomial going on. And this, to me, does not look whatsoever like a perfect square trinomial, so I'm not going that route. So I guess I'm stuck trying to do the factors of 25 and 6 that add up to 5. And this would really be negative. So I think I can get there from 10 and 15. And I'm showing this slightly different. I'm showing this kind of more of the old prime factorization route, where you could break things down that way like we did earlier in the section and earlier in your math background. So I get 10 and 5, and that means that the positive value has to win the war, win the battle. It's kind of dramatic, sorry. So there's a negative right there in front of that 10, and I'm going to rewrite this as 25x squared minus 10x. Order doesn't matter. I can do 10x and then 15x, or I can flip it around. You'll always end up with the same result. From the left side, I can factor 5x out through setting up this grouping problem, and I'll have 5x minus 2, and then I'll have plus, let's see what happens if I factor out a 3, 5x minus 2, which usually tells us we did the right choice, the good way of going about the problem. I scan through it. I ask myself if anything else can be factored. So that thing on the right says 5x minus 2 if you can't read it. So we've got 5x plus 3 times 5x minus 2, and that one's completely factored. On your own, set up and complete number 3. I'm going to put the answer up and clear this out in just a moment. That's how I've did it. I've done it. Okay, so I've rewritten the problem. You do the same, and I'm going to uncover what's on the right. So go ahead and finish this all the way if you can, but if you get stuck at the factors choices, that's going to be the first thing I show right about now. With it being larger numbers, it just takes longer to get there, but 15 and 12 would multiply to give you 180, and if I wanted to figure out which of those two options has to be negative, then the minus 15. Now, if that was the hint you needed, pause the video and finish it to completion. There's the end result, assuming I didn't make any mistakes. The quantity 3t plus 4 times the quantity 3t minus 5. Alright, this is probably an appropriate point to pause this video or stop it and jump into making a new one from scratch. So this is the first of a couple videos that deal with perfect squares and factoring, and I think these are easiest if you just see them, and then they of course are going to work their way towards solving.